confirm that you can hear me or not. If you can hear my voice, number 5, please. This time, being wrong system already. And the quiz is fixed already. 20 days later, online, open book. And all the lecture topics from week 1 to week 5. This week is week 4. Week 5 is next week. From week 1 to next week, week 5, will be tested. And more instruction will be given by the course coordinator, Professor Lam. So usually the quiz questions are so easy to solve, much easier than final examination. Please do attend, do the quiz about 20 days later. Now, the first question, however, this is not our tutorial question. This is a PYP question. Explained in the lecture, online lecture by Professor Lam, the lecturer. You see, you will see something like this in 2015. In 2020, you may see another system, but similar to this. He explained to find how to find the transfer function GS, which is the ratio of YS over 2XS. So these 4 steps are explained by Professor Lam, lecturer, and also should be not remembered because it's open book test. So you need to follow this step. In fact, it's very easy. Separate the spring, dampers, and mass. Because we only have mass, spring, and damper. Yeah, and sometimes damper is missing. We only have spring and mass. And use free body diagram to write the equation of motion, Newton's second law. Then finally, we take a Laplace transform, and then if the function of time is needed, then we need to do inverse Laplace transform. Okay, we will learn today again. This is quite similar to many of the procedure in many courses. For example, in MA 2002 TON, we also do this, right? In that case, we separate all the links, and then we do analysis of the links, and then we draw free body diagram, and then set up equation, second law equation or Laplace. No, D'Alembert principle. Remember, you did, because it's 3005, you did 2002 TON, many of you, not all of you. Then the only difference is in this code, we do Laplace transform and inverse Laplace transform. That's the only difference. The rest would be the same. Free body diagram is very important. But since you have taken, most of you have taken MA 2002, you know how to do already. So only Laplace transform and inverse transform would be new to you as third year student. The majority of you will be third year student. Okay, now this is PYP, another PYP, because this is the first one in year 2015. In another year, you see, 2019, 3 years ago. This is another PYP. Same thing. We student needed to separate the spring like this, damper and mass. Do we have a damper? Damper here. Yeah. But in this case, MG is considered. In this case, MG is considered and analyze the force on spring and damper. This is step 2. And then you see, he explained, the lecturer explained. And then after that, we use Newton, we draw the free body diagram. The free body diagram, here we only have 2 forces. Okay, and then you Newton's second law. We can set up equation, and then use the Laplace transform to get the transfer function. How many marks? Let me see how many marks in that year. Not clear, but in 2015, 12 marks are given. 12 marks are quite a lot, a lot of marks. So this year you may also see this in CE test 1 and final examination. Okay, let us start. This one of the 2 questions, easy. Write the differential equation for the mechanical system shown below. Here we only have a mass and spring and damper. So where F? Here we have 4. This force, F, is the force input, and X is the displacement output. So we need to write the equation. Although the question may not ask us to do Laplace transform as tutorial, you can write introduce or solve to take Laplace transform and solve or get the transfer function. But in the examination hall, if this is a requirement, then differential equation only are required, not the transform, Laplace transform. But usually the examiner would ask student to add one more sentence, to give ask student to give y over f. In this case, x over f. That means you have to provide Laplace transform. Function, transfer function. Okay. How to do? Step 1, separate the links in TOM, but here to separate the spring and damper and the mass. So this is the output, right? But the spring has X. This is the damper. So assuming in this direction, these two damper and spring would be expanded. Then on the other hand, on the right hand side of the mass, then we have a compressed force because the motion is to this direction rightward, right? So of course we also have K2, C2. Quite simple actually. Then we see the mass. The mass free body diagram is drawn already actually. This F is input given by the examiner. The input is a 4. Okay, we can use small one, but if you use this one, this is not big mistake. It's not big mistake. No mark would be deducted because you can see we are quite generous. So this F, this M is a mass. We have four more forces. On the left hand side of the mass, you can see we have this spring force, okay, and damping force in left wall. Because according to Newton's third law, action and reaction, of course, if the spring and damper are expanded, then there must be a reaction. To or these two reaction of these two opposite direction parallel, opposite direction equal. So this is a spring force. This is a damping force. Then similarly, on the right hand side, we also have two forces opposite to these two forces to this direction. Because it's compressing the spring and damper will give a force each to left wall, right? This is damping force from spring to and spring force from spring to damping force from damper to. Okay, this is the output, which is the displacement of this mass. So with this free body diagram, we can apply Newton's second law. The Newton's second law, right? The summation of all the forces equals ma. X double dot would be A is acceleration, linear. We do not consider mg. Why? Because it's horizontal. Mg is not required. It's horizontal motion. So in this motion horizontally, mg doesn't have an effect. So otherwise, if the question asks you to consider mg, like one of the PYP question explained by Professor Lam, in that case, mg must be considered because the motion is vertical. This is a horizontal, so no mg can be considered. Friction force also is not considered. Friction force, assuming it's very smooth in this direction, there is no friction force. So both the friction force and the gravity force are ignored, are not considered. So then we have 5 forces. You see, one is F. These two to the because X this is positive direction. X is positive direction is positive. This is positive. These two are negative. These two also negative because all of the 4 spring forces and damping forces are left the wall. Okay, then equal the summation of all the forces equals ma. A is acceleration, right? Represented by double dot x, x double dot, dot x dot x double dot. So either way, you know what we mean. So m is the mass. Okay, then we do some rearranging because this is a standard equation. Normally we want to do this. Ma plus c x dot. This is a velocity, and then k, the total k, k1 plus k2. X is spring force, X is displacement, this is the velocity, and this one is the acceleration. So this is standard for. So then we, because it's all negative, so we move this negative item to the right hand, and then do a swapping. Then the right hand will become left hand side. Then this F is positive, right? Very easy. No one could make any mistake, I believe, right? So after that, then the last step is to take Laplace transform or perform Laplace transform. This way we can use the table, Laplace transform table. In fact, it's very easy. You do not have to see the table. Here, I do not see the table. We know this x dot. When you take a Laplace transform, we assume not only this x dot, double dot, or x dot, or x. We assume when we take the Laplace transform, all the initial value would be, or condition would be 0. So we only consider this. This will give you s squared multiplied by capital X, capital letter X. Maybe let me use our English large X. So this is Laplace transform, right? But we have X squared. Why we have this? You see the table. The table will give you this. But after doing many times, we automatically remember. When we do this, do Laplace X dot equal the Laplace transform of X double dot would become S squared multiplied by X. Okay, and then don't forget this m. Okay, the next one is x dot velocity. Velocity, you take a Laplace transform, you would get s plus multiplied by xs. So, but also don't forget about don't forget this c1 plus c2. Easily we make careless mistake by missing out this c1 plus c2. So don't do that. And then similarly, this is easy. When you do that, you only have x multiplied by the coefficient, which are k1 plus k2. So now we have this. So then this is the input, this is output. The transfer function is the ratio of input sorry, output to input. Output to input. So x over f equals, of course, 1 over this part. So we have already. So do we need to solve? No need, because the question doesn't ask us to solve. Just ask us to give. In fact, we do not have to take the Laplace transform. Right? Why? Because the question said, this historic question said, write the differential equation. No other instruction. So in fact, we could stop it. This is a differential equation without doing further. Proceed further to perform Laplace transform and get the transfer function. The last two steps are not necessary for a question like this, differential equation. If you are not very sure, you can raise your hand during final examination. The examiner will tell you whether the examiner wants this only or plus this one plus transfer function. You can ask him. Okay, quite simple, right? 4 steps. Let me summarize what we did. We say first, we separate springs and damper and the mass, this mass. And then we analyze each of them. But usually we can put the two together. We can do, but this is analysis of each of them. But to save time and space, we can put two together, then another two together, and then finally mass. Then we draw the free body diagram. No, free body, diagram. Force, you give force, all the forces. And then you set from free body diagram, you get you apply Newton's second law, you get the equation of the summation of all the forces, in this case only in one direction, not in any other direction. In other direction, then you complicate the problem here, because the question asks us to consider this direction only actually. So you consider this only in this direction, x direction. So the summation of all the forces must be ma, and then you set you set the equation, you do some rearranging, you get the so-called standard differential equation. That's all. The rest are not necessary for this derivation, I believe. But there are many cases the question asks students to further to perform Laplace transform. Then you perform. You can see the table, but this is easy to remember. I won't see the table. I can do this. And then you take the ratio of x. The x is in this case output to y. F is input in this question. Then you get this transfer function, right? Any question? You can ask me question from time to time, or you want to wait for 20 minutes more, 20 more minutes, and then you ask me question. It's up to you. You can stop me at any time. So the second question, today we only have 2. Okay, write the differential equation for the mechanical system. Sorry, we have one more. I believe 3. Yeah, this is the second one. Write the differential equation for the mechanical system shown below. Okay, and then if different displacement input y is given, then we can this is string. I would change, it's given by I don't know who, which result in a displacement output. That is x. We should add that is x. X is output. F is input, but displacement input. Different from the first question. The first question the input was 4, but this time is displacement input. Then here we only have one spring, then one mass without any damper. How to do this? Again, 4 steps. Number 1, separate the spring and the mass. This is a spring. We have to make assumption. This assumption may not be 100% true, like what we did for TOM MA2002. We taught students that to make assumption would enable us to set the equation. After solving the equation, we may or may not need to do correction of the assumption. No need. Yeah, it's very often. So here we have this, right? Although vertically there is no MG, there is no instruction to student for considering MG. So we do not consider MG. No MG here. So we assume X. Why? Because we want to simplify problem. If you consider MG, you consider friction force, whatever else, and then you would complicate the problem, and then time is not sufficient, and you may deliver a wrong answer. So at least the question specified to consider what. Just follow out what we see. Seeing is believing. We see this question like this, we just do this. So we assume x is larger than y. Then we will have a spring force in this direction. This direction may not be downward, but anyway, in this direction, we can assume this system is horizontally represented in this direction only, not downward necessarily, without considering MT, because the next one is the MT is not considered. You see, just in this direction we have this x, but x is displacement, not force, not force. But here we have 1 4. However, when we set up equation, say 1 4 equals ma. So ma become a force actually. You learn in TOM, ma can be considered as inertial force, right? So this is well balanced. But this is a dynamic system. So we can do it this way. We use the Newton's second law directly, or D'Alembert principle. But D'Alembert principle is not handled in this MA3005. But the knowledge, experience in TOM can help you to understand better, deeply, more deeply. So then, according to Newton's third law, if we have a fall from spring, force to M, then M, the mass would have a force in opposite direction. These two are equal opposite, right? This force is called what? Spring force in this direction, not necessarily upward, in this direction. Because I said I treat this sitting in a horizontal plane, in this direction. And then 1 force only. Some would say 1 force cannot get balance, but here we do not consider balance. Why? This is not static force analysis. This is dynamic force analysis. Dynamic force, dynamic system analysis. So 1 force, the summation of all the forces, only 1. Assuming this direction is negative, this direction positive, okay, negative, equals ma. According to Newton's second law, this is allowed. In fact, according to D'Alembert principle, if you take TOM, you know what D'Alembert principle is, or you can use Google search to search D'Alembert principle. And then well balanced actually. One is in this direction, another in this direction. Ma dot also in this direction, right? Double dot, sorry. Ma or double dot is a. Ma is this direction. So well balanced in one direction. Dynamic equilibrium is achieved, right? Then you do some rearranging, and then you can see without C, the damping coefficient. This is standard one. This is a force. This is a force. Ky is force. Spring force. This is also another one. Okay, but here because X is output, then Y is input. Displacement input. So we put it this way. However, if you do in another way, I think if I mark, full marks can be given, or close to full mark can be given by me, but I do not mark for final examination. So you have to ask Professor Lang whether another form is allowed. I believe yes, another form is allowed. Because this is not the primary school. This is not a secondary school either. This is a university. University give professor and also student academic freedom as long as the principle is certified. The form is not the most important. Okay, the concept is correct. So now the last step. We perform Laplace transform. As I mentioned, you can see the table. You can follow the lecturer or follow me to do it this way. This is the M here. X dot double dot. If you take the Laplace transform, you get the S square multiplied by X. This is X, right? The large capital letter X. And then the K X. Then you get K multiplied by X. The K is coefficient. This M is easily forgotten. So don't forget this M. Don't forget this K. But this S2 also must be given. Then Ky, the small y, right? Representing the input displacement. But this is larger y. This is the Laplace transform of y. Then you take the ratio of output to input. This is input, right? From using this equation, you can easily get it. This is the final solution. Okay? Too easy, right? Then the last one. This is the last one. Sorry, I said 2. We have 3. This is the last one. This one is quite complex, relatively complex or complicated. But if we do step by step, we really can solve. No issue, no big issue. It also includes the concept of week 1, week 2, week 3. This is week 4, right? The question asks us to consider the rotational system. The rotational system having a flywheel, with the inertial J is given 100 kilometer square. And viscous damping coefficient B. That means this damping coefficient B, or this device, or this element in the machine, mechanical machine, would result in damping torque, because it's a rotational system. Damping torque, not force, torque. This B has a unit. This is a unit shown in this figure. Our job, we have 2. One, find the transfer function. You see, this is omega. This is omega. Omega is what? Omega theta is used to represent the angular displacement, the angle, rotational angle, angular displacement. And the omega typically would be used to represent the velocity. of this rotation. This rotation of system, right? So this is the Laplace transform of omega t. This is omega s over t. T is the input because if it is top, this small letter, larger letter would be t. So this is the input top. Because of the top, then we can have the so-called Newton's second law equation. So in fact here it is explained. The question is a good question. Explain. This omega is the Laplace transform of angular velocity. And this tau is the input tau. Then the Laplace transform form would be t. And then second one is using Laplace transform to find out the omega t. So this is a function of time. If the top value is given, then what is the steady state value for omega t? So this one is easy because we have practiced 2 times already today. The next one also easy. We did this in tutorial 2, tutorial 1 to tutorial 3 in week 4, right? This can be done. So although we cannot do group discussion, but we can do Q&A. You can stop me at any time and ask me question. Otherwise, I will explain and wait for your question at the end of the tutorial. We still have time. Don't worry. So now, how to do the first step? Okay, for A, for solution A. Then how to do? First, we separate. We can separate. However, we do not have other element. We don't have one, so we can directly, in fact, omit. Because free body diagram is given already. Free body diagram. Fourth, the top in this case is given already. We can directly from the free body diagram to set up equation. The equation according to Newton's third law, all the summation of all the top must be equal m alpha. Alpha is omega dot. Omega dot is alpha. Omega is velocity. Omega dot is acceleration, angular acceleration. So by using Newton's second law and then do some arrangement, we get this standard form. Directly, many of us could do this directly from the figure. That means J omega dot, the angular acceleration, plus B. B is coefficient, bigger, large, or capital letter or small k letter. That doesn't matter. That won't give you trouble. Here, let's say we use small y. That's standard y. Multiplied by omega. Omega is velocity, angular velocity, equal the top input. Top is input top, right? The top. Then we take Laplace transform by using the table or directly. We know how to do already, right? And then we do some calculation. I omit how to do because we did 2 times, and Professor Lam also you did a few times in his lecture. So this is too easy. Directly from here we can get this actually. From this equation we can get it. Okay, this transfer function. But there is given. There is 100. Then put 100 here. B also is given. So B is given 10. Then put 10 here. Right? So this is the transfer function with all the values, the variable, known variable value given, right? So now we need to, in fact, it finished already. A finished already the transfer function. And the marks must be, let's say we have 8 marks, 4 for question A, another 4 marks for question B. 4 marks are given already. Should be given. So now, then the next one, using Laplace transform, find omega t. Now t, not s. T is time. So this omega t is a function of time. If tau is 100, same. This is 100. What is the find this omega t first, and then calculate the steady state value. The value, not error, the value for omega t. Then how to do? We are familiar. We do this one. Remember, this is our transfer function, right? However, this one means we do have this ts. So this ts. Because here this is a transfer function. And omega s over ts. So we need to calculate omega t. We need to calculate omega s. So ts must be given already, 100. But by using the table, you see the table, then we know this 100 is tau. But ts is 100 over s. How do we know? From the table. You see the table is 100 over s. So now we have this. Because the ts must be in this side. We can move the ts to this side. So ts is here, right? Then these two are like something like this, right? And then we need to determine A and B in order to do a Laplace inverse transform, right? Or inverse Laplace transform. So that's my question. Today's first quick question. When we have this form, this form fs, but here is omega s. Previously, last week we had fs, right? And then select the correct answer among the following. What could be the values of A and B by clicking 1, 2, 3, 4? Come on, click 1, 2, 3, or 4. 1, click number 2. Now 3. If you do not know, click the 1, 2, 3, or 4 only. You still have a chance. In fact, I did some CE test before student could do in week 7. I found if we have 4 answer, I got 20% marks without doing any calculation, just select randomly. As I said, 25% of the chances would give you 25 marks on average, but I got 20. You won't get 0. By guess, you won't get 0. So now we have all the students selected 7. You are right. A is 10, B is minus 10. How to do? We know already. You see, because you select 2 values of x smartly. And this one could be s, because if this s, this item disappears, this term disappears. Then we only have this. This is 0. 0.1 multiplied times a equals 1. Immediately you get a to be 10. Then you select s to be minus 0.1. Then this term would disappear, 0. Then b equals b. This one, right? This is 1. Then b, s is minus 0.1. Yes. Then you get minus 10. To be b. So after that, you take you get this, right? So a, b are determined already. Then you use the table again. No need to memorize because open book. Open book for test. Restricted open book, closed book. I cannot remember for final examination. You check with the lecturer. But in your future, when you do control, you will have a table available. Open book. So by using this table, A and B determined already by you, 100% correct. So what could be the omega t? By taking the inverse Laplace transform of this one. So what's the answer? Click 1, 2, 3, or 4 only. Don't click number 5. This one was clicked by me. Still is recorded with residue selection or voting. So do you think still this answer 2 is correct? I'll give you some hint. You did it many times already in the tutorial room. The day you do online. For the first term, you consider this second rule or second function, right? Then for the second one, don't forget about minus. We all have minus here too. Then you consider the last one, this one. Then this would give you the correct answer. So the class is divided. Then you get 2 again. But not guessing. I believe you did real calculation or inverse Laplace transform. This is correct because this one gives you this. Then another one gives you this. Okay. Now, once we have this, you can guess, or you can use this function to do calculation, or to do analysis, or to make the conclusion. What is the steady state value for this omega t? 0, 0.1, 1.0, 10. Click 1, 2, 3, or 4 only, please. When you do your CE test, you may do this, you have 4 answers. You select 1 only. You get 0 or 15 mark or 10 mark. Today you do, I do not know who you are because I won't check. If I check, I know who did wrongly, who did properly or accurately. But I won't check. I just give you 1, 2, 3, 4 values, and you select one. You make a guess, fine. With this equation, directly we can get the answer actually. Yeah. So 1 selected 2, 0.1, and all the rest of us selected 4. 4 is correct. Why? Because when steady state value means when t is large enough, this t is large enough or long enough. Let's say t is 100 seconds, 1000. If 1000 t is not large enough, you can use 10,000. Then by using calculator or just observing the equation, this would be 0 or close to 0. So you only get 10. So 10 is correct. For this student, you did it wrongly, but no worry. You see, I explained. You can ask me a question again or ask your friend. This by the second term, when t is a large value, this would become 0. The only one is steady state value. So 1 multiplied by 10. Don't forget about 10. So we get 10. Okay. So easy. You see, okay. And also we can use this limit equation. You learned this when you were a JC student or poly student, right? Omega t. Steady state means when t approaches infinity. Yeah, this is a 1. So from here directly you can get, but we can also use the final value theorem. Then you have this, right? Remember we did, and then you get it. Why? This is directly, using limit, right? Because this one would be 0. This would become 10, no change, right? But this one is so-called final value theorem, because the omega s is available. So you directly use this, or this. It's up to you, and then you get 10, right? Okay. Now, we finished already. So we just see B, just list what you have done. Using one of them. No need to use two. But here I give you two methods are available. Okay. In fact, third, without doing this, just by observing the omega t function, you can achieve this. 10 is a steady state value. This one is not necessary because the question doesn't ask to plot. But in week 10, week 9 or 10, you will learn how to do plotting. So this is not necessary. So before you leave, we still have 3 minutes before the question. No, the tutorial can be closed. Then after that, you can ask me questions. Some of you can ask me questions. Some students ask me this. This is last week's question. The question was this, sir. He asked me. So here we have to. The hint is since the system is linear, then use the property of superposition. So what is superposition? What is a linear system? Linear system is explained by Professor Tango. You know you have a LAMS lecture, right? Professor Tango has left NTU, but he recorded his LAMS lecture. Still, the LAMS lecture is viewed by students. This is his lecture note. In his video, he explained. For example, if we have ft and gt, ht equals ft plus gt, this is the linear system. And then you take a Laplace transform, and then you get this fs plus gf. So this is the number one most important property, or property, right? Yeah, this table tell you the property actually that the linearity is maintained for function, time function, and Laplace domain transfer function. Okay. In fact, I searched the internet. The internet tell me there are many explanations. I like this one. In fact, this is what I told students. Students ask me, what is a linear system? I do that. A system is linear if and only if it satisfies the superposition principle. Very simple. If superposition principle can be satisfied, then the system is a linear system. I also found another definition. Function, linear function. Similar to this, a function that satisfies the superposition principle is called a linear function. So all ask to see what superposition principle is. So this is the one from the internet. You can do your own study. Only one more minute. The superposition principle states that for all linear systems, the net response caused by 2 or more, 3, 4, 5 stimuli is the sum of the responses that would have been caused by each stimulus individually. Understand, right? This is what we did. I will show what we did last week. In other words, if input A produces response X and input B produces responses Y, then input A plus B produces response X plus Y. So we can see each separate them, A and B. We set B to 0, consider A only, and get X. Then we set A to 0, consider B only, separately, we get Y. Then the final one, because the linear system, would be X plus Y. Simply like this. So this is called superposition principle. This principle is applied to many courses, not only this course. This is M83005, right? In another course, I'm teaching TOM. We also use this superposition principle to simplify the approach of a very complex system. And in another course, I'm also teaching called MA2009, electrical devices, electrical circuit design, etc. We also do this. Remember, you took the 2 second year courses. In year 1, we have MA1008. We also learn how to simplify problems by this principle. Yeah, divide and conquer for Python coding, Python programming. So this is very common method, something like Newton's second law. Really, it would be applied to solve many complex problems. For example, this one. This is very complex. Because we have not only input, reference input, we also have a disturbance input. We also have a noise input. We did this last week, but we use this principle called the superposition. First, we set D and O, this D and N to be 0. We consider R only and the output. We get the transfer function. And then, similarly, second time, for the secondary, or second step, we consider D only. By setting R and N to 0, we get another transfer function. Lastly, we set R and D to 0 and consider noise only, and then we get another transfer function. Then we do this X plus Y plus Z, right? As what I showed. So we have 3 transfer functions to be summed up. Then to the final one, to have all the 3 input and 1 output. Then you do the calculation, you would get this transfer function. No need to see the rate. This transfer function, very complex. But if you put all the value in, wow, yeah, it's quite no, it's simple actually. But this is the final one already. This is standard equation for all the 3 as a denominator, but the numerator should be helpful. Not only R as an input, but also D and N representing disturbance and noise. Okay, so this approach is called superposition. Okay, enjoy your study. Thank you for attending this online tutorial. It is recorded for other students to view and also for you to review. Again, if you have a question, turn on your microphone and ask me a question. I have time to teach you more, answer your question. Otherwise, you can leave. Happy Lunar New Year. Enjoy the holiday. Tomorrow, we have to go back to NTU to do study, right? So we still have half day today, half day plus, yeah, to celebrate the holiday. Thank you. Any question? No question? Then you can leave this session. Have good time. One student is still here in the virtual tutorial room. Do you have a question? Okay, no question. Okay.